I use the T100 basically for intermittent problems.
I think that the days of simple sensor failures are gone.
When we use a T100, we use that to do a more thorough check and make sure that everything is working properly.
The T100 has been continuously updated and refined from its early days when it was known as the CAMS machine. The T100 now has revised touchscreen software. When a finger breaks the light beam, the corresponding selection is highlighted. But now the selection can be changed. When a finger is dragged across the screen, a different selection is highlighted. However, the selection is not made until the finger is moved away from the screen, restoring the light beam. The touch and drag feature is especially useful when working with screens that have a lot of available selections, such as when looking for service bulletins. This enhancement was one of several made possible by conversion to the new C language. Even with the changes in the screen, basic T100 operation remains the same. When the machine is turned on and after pertinent vehicle information is entered, all tests and information can be reached through one of three main menus. The diagnostic menu provides access to diagnostic tests and tools to gather and display AL/DL data for troubleshooting. The service information menu accesses service and technical information, including service manual revisions. The terminal menu accesses information that aids in the operation and maintenance of the T100 machine. Since it mostly contained information on the T100 machine itself, the terminal menu probably was not of great interest to drivability technicians. But now there is a new service under the communications menu. When dealer communications is selected and the telephone line is connected, the Vehicle Information Service System, or VIS, can be accessed using the keyboard. Using the vehicle identification number, VIS locates campaign bulletins that apply to the vehicle being tested. VIS also tells whether or not the vehicle has been repaired under the campaign. For example, if a 90 Skylark with a quad-4 engine comes in with a complaint of an intermittent misfire, the VIS shows the campaign to replace the integrated direct ignition coil because the coil can break down, allowing arcing between terminals that may cause a misfire, rough idle, or no start condition. In addition to campaign information, VIS maintains warranty information on each vehicle. With the many different warranties, including the 1987 6-year 60,000-mile warranty to the original owner, VIS provides a useful service. You know, the T100 has always been more than just a diagnostic machine. Well, now the T100 is also an even better information center. The Service Information menu allows access to service bulletins, PROM identification information, vehicle specifications, and technical tips. There are several ways to access service bulletins. Perhaps the quickest way for Buick technicians is to first select the model year. Then limit the search to Buick bulletins by selecting Buick. Next, select the type of engine or transmission model, depending on whether you are searching for an engine or transmission-related bulletin. In some cases, a body style should be entered, but this may limit search results. When looking for a suspension or brake system bulletin, body style is more important than engine type. An engine or transmission bulletin is probably not specific to only one body style. Finally, the symptom is entered. By the way, if you remember seeing a bulletin, but it is not identified during your search routine, rerun the search, leaving out the symptom. If you still don't find the bulletin, rerun the search and leave out a second search item. Often, you will find the bulletin you want. This is a good point to mention another feature of the touch and drag screen. If you make a mistake when selecting an item, or if you decide that another symptom better describes the problem you're diagnosing, just touch the same selection again to cancel the selection. When looking for service bulletins, it's best to start out as specific as possible. The T100 contains service bulletins for all GM divisions. If a general bulletin search is conducted and the search produces over 255 bulletins, the T100 does not display the bulletins. Instead, it asks that the search be limited. If the search is successful, the T100 lists the titles of the bulletins that are available. To view a bulletin, touch the screen. If a service bulletin has a diagram in it, figure appears in the menu at the bottom of the screen. To see the picture, touch the Figures button. If more than one figure is available, there is a box for each figure. Touch the appropriate figure box. The figure is the same as the diagram that appears in the service bulletin. With the T100, sections of the diagram can be enlarged by pressing Zoom. After pressing Zoom, touch the screen. A box appears. Next, drag the box across the screen until it surrounds the section of the diagram to be enlarged. When the finger is lifted, the diagram section is enlarged. And that brings us to PROMs and PROM updates.
We scan the engine and make sure everything's working properly the way it should before we start looking at PROMs.
And that's good. Some drivability problems have been solved with new PROMs. For example, the PROMs listed in Bulletin 87-6E-8 for 1987 3.8-liter engines. Another example is that some owners of 92 Roadmaster sedans may complain of a spark knock under light load. An update PROM has been released with refined calibrations to address detonation complaints. However, when a detonation or idle search condition is experienced with this engine, the first step is not to use the T100 PROM ID specifications to see if an updated PROM is available. First, the systems that could cause spark knock should be checked. Base timing should be correct. The electronic spark control system should be working correctly. With the engine running, tap on the engine block near the knock sensor. If the system is working, the knock signal should read. If the engine is running warm, detonation can occur. Therefore, coolant temperature should be checked. Coolant temperature should be between 85 and 101 degrees Celsius. Two other systems that merit inspection for a detonation symptom are the EGR system and the thermostatic air cleaner. These systems should be checked by performing the procedures outlined in the service manual. If all the above preliminary checks prove okay, use the T100 to check the PROM identification. PROM ID is given in the ALDL data stream. Let me suggest that it's always a good idea to write down the PROM ID number. To see what PROMs are currently recommended for an engine, return to the Diagnostic menu. From the Diagnostic menu, go to the Service Information menu. From the Service Information menu, select PROM ID specifications. Then select the model year. The engine type screen appears. The information on the engine type screen shows the model year, engine type, and engine code. Engine code is the 8th digit of the vehicle identification number. Select the desired engine type and the PROM applications chart appears on the screen. The first column lists the vehicle model. Next, look for a scanner ID that matches the number shown on the dynamic display. The column under Comments displays additional information about the PROM. For example, if there are no comments, the PROM in the vehicle is the most current one. If in the Comments column there is an S/S and then a number, it means this PROM has been superseded by a new PROM number. If it says Fix Codes, it means the PROM listed is specifically updated to repair the listed codes. In some cases, the comment refers to a service bulletin. It should be remembered, however, that a PROM or MEM CAL should not be updated just because a new one is available. Unless the vehicle is suffering from a specific drivability complaint and a PROM is listed in a service bulletin to correct that specific complaint, the PROM should not be replaced. Otherwise, replacing the PROM does not correct the problem. Repair dollars are wasted, and the customer's car is likely not to be fixed.
You can have a stall condition created by a bad spark plug wire or something like that and put a PROM in there and it's not going to cure it. You have to make sure everything else is done properly before you use the PROM.
A case in point, this car happened to have a malfunctioning thermostatic air cleaner. Also, be sure to monitor recent service bulletins to keep track of PROM or MEM CAL updates. In some cases, a bulletin has been released for several weeks before the T100 database is updated. In this case, the T100 PROM listing may be misleading and prevent the installation of an updated PROM in a vehicle. To see what vehicle specifications are currently recommended, return to the Service Information menu. After choosing Vehicle Specifications, the first selection screen appears. Select a year and then either engine, transmission, or tune-up specifications. For example, if engines and 1990 are selected, a screen appears listing all GM engines for 1990. Select a specific engine to help limit the search. To view the specifications, touch the box containing the title of the desired information. AC spark plug information lists the latest spark plug requirements for all GM engines. Other screens provide engine specifications, engine fastener torque specifications, and tune-up specifications. The T100's Vehicle Specifications section is not meant to replace the Buick service manual. Rather, it is designed to complement the service manual.
We do bulletin searches almost every day.
Sometimes, service bulletins are released that revise vehicle specifications. These revisions are recorded in the T100. When an asterisk appears next to a specification or figure, it shows that the specification or figure is an update. A service bulletin was released with revised specifications. If the revision was not made in the service manual, however, the technician making the repair wouldn't know of the new value. Again, these revisions are recorded in the T100, providing technicians with accurate, up-to-date specifications.
In most cases, I look through all the bulletins to see if there's anything that would relate to that particular problem before I start. It's usually a good place to start.
In addition to the terminal menu and the service information menu, there is a diagnostic menu. Diagnostics provide the ability not only to display ALDL data on the dynamic display, but also to perform fault isolation procedures for specific circuits and to perform special tests, such as the cylinder balance test. Dynamic display allows the technician to view the ALDL data stream as the engine runs. Many conditions can be diagnosed by inspecting data stream parameters while manipulating various engine controls or checking suspect components and wiring harnesses. Dynamic display also displays trouble codes. Trouble codes may differ from engine to engine. To get a definition of a trouble code, touch the code. On vehicles that have bidirectional ECMs, a clear code box appears on the screen. By selecting Clear Codes, both history and current trouble codes are cleared. To run specific component tests, the T100 features fault isolation procedures, or FIPS.
We usually use the fault isolation procedures after we use a diagnostic test, and then it'll usually bring you right into the fault isolation procedures.
FIPS have the tightest parameters of all T100 tests. Experienced technicians examine the ALDL data for a parameter that is out of specifications, such as this idle air control motor reading, and then select Tools, and next, Circuit Diagnostics to reach the FIPS. The improved FIPS on the T100 save time in many cases. For example, it would take a technician at least 40 minutes to perform these IAC valve checks. The IAC FIP uses the speed of the computer to check the wiring harness, the motor, and the signal from the ECM, and it only takes a few minutes. FIPS are the most comprehensive T100 tests. They accurately check systems. However, they are sometimes misused. FIPS do not locate intermittent problems, unless the problem happens to occur while a FIP is being conducted.
The fault isolation procedure helps us out because it tells us what to do, tells us what to hook up, what to disconnect and then hook up, and the CAMS does the majority of the work for us. We just simply do the mechanics of it.
Intermittent problems are difficult to see when looking at the ALDL screen. Even more difficult is to compare one parameter to another parameter, especially when the ALDL data stream is longer than a page. Rather than using the FIPS to diagnose an intermittent problem, it's better to use a data plotter. Data plotter presents ALDL data as a graph. To enter data plotter, select Tools from the dynamic display screen. Then select Data Plotter. Touching the up and down boxes moves the highlight around the screen. To view a parameter on the data plotter, touch Select. Up to 3 selections can be viewed at a time. After making data stream selections, push Done to start the test. Or to start the data plotter while doing a wiggle test or under other special conditions, the data plotter can be triggered by a remote control. The plotter graphs 20 data streams. In this example, throttle position and engine RPM should reflect each other closely. If, after viewing the scan data, you decide to view additional parameters, touch Quit to return to the plot selection menu. 3 more selections can be made. When Done is touched, the plotter plots the same data streams for the new parameters. The data plotter can be used with the vehicle service monitor, usually called the VSM. Even when connectors are wiggled or engine speed is varied, many intermittent problems do not occur while the vehicle is connected to a diagnostic tool in a service bay. Using the VSM to record data while a fault is occurring provides a 3 times better chance of catching the problem.
Yes. Using the VSM can be very handy for very intermittent problems. There'll be times where the car may only act up once in a great while, and you can't be monitoring everything at that exact moment. And the VSM being hooked in and recording, you know, all the driver has to do is press the button and it records the time that the problem actually occurred, and you can come back to the shop and look at the screen and play it over and over and over again until you finally see what really happened. And sometimes it's just more helpful just eliminating things that are not the problem.
The VSM is a portable ALDL data recorder that is used to find intermittent problems. VSM data is accessed from the main diagnostic menu. The VSM must be programmed before it is used in a vehicle. To program the VSM, follow the step-by-step instructions on the screen. Keep in mind that, like the Tech 1 snapshot mode, you have the ability to program one of 3 trigger points. Be sure to use this to your advantage. To record data, place the VSM in an area where it cannot be accidentally touched or moved, and plug the power cord into the cigarette lighter and the ALDL cable into the ALDL connector. The green light on the trigger handle should light. When the ignition is turned on, the amber light on the trigger handle should light. Drive the vehicle under conditions similar to those present when the symptom or problem occurred. When the symptom or problem occurs, press the trigger to record ALDL data. The green light will flash while the VSM is recording. If possible, record the event 2 different times. You may continue to record, but only the last 2 recordings will be retained in the VSM. Follow the instructions on the T100 to load the data into the T100. When the data has been retrieved, disconnect the VSM from the T100 and follow the instructions on the screen to view the data. The data is displayed on a screen that looks like the dynamic display screen. To enter Data Plotter and look for intermittent problems, select Tools. Data Plotter works the same, no matter whether the data is coming from the ALDL or the VSM, but will be at a faster rate when coming from the VSM.
I think that the scan tool is very imperative to use.
Quality control is going to be better, the parts are going to be built better.
It's really nothing that you can't fix pretty quick.
Scan tools are designed to help technicians find drivability problems. Knowing how and when to use FIPS, Data Plotter, Snapshot, and data pairs help technicians make better use of their time. Remember, the upcoming drivability programs provide detailed information on engine families. Specific diagnostic routines and troubleshooting tips for these engines will be examined in these programs. By using diagnostic scan tools in the way they are intended, we can keep Buicks on great American roads and out of the service bay.
Because of the intermittent nature of some ECM symptoms, many service technicians have been subjecting the ECM to vibration or shock testing, more commonly known as the tap test. This procedure involves tapping on the ECM case while the engine is running. While it is generally true that if the engine or ECM falters during the tap test, an intermittent internal ECM problem may be indicated, this may not always be the case. If too much force is applied to the ECM during the test, you may cause an ECM reset or glitch, creating a momentary stall, miss, check engine light, or loss of serial data, or damage which will cause a failure at a later date, or an immediate ECM failure. Here's why. Some of today's integrated circuits are surface mounted, that is soldered to the top of the circuit board, not through the board. Also, there can be up to 52 pins soldered in a very small area. Any flexing of the circuit board places the IC solder connections at risk of damage due to mechanical overstress. Such damage might show up immediately, or it might show up later. Circuit board deflection can even occur as a result of striking the ECM just using the palm of your hand. If struck on the bottom, the side opposite the MEM CAL, the ECM's aluminum outer case may deflect inward far enough to contact the electrical leads attached to the circuit board. The clearance between the case and the circuit board is closest on the bottom side of the ECM. Once in contact with the case, the ECM electrical components will be shorted directly to ground. Although this shorting may not cause permanent damage, depending on which circuit is involved, the potential is there. But even if permanent damage is avoided, a short on any of the circuits will cause a disruption of normal ECM operation for the instant that the short occurs. This may cause the ECM to reset, creating the false impression that it is vibration sensitive or faulty. Reset is the ECM's normal way of coping with large voltage spikes. An ECM reset does not necessarily mean that the ECM is faulty or damaged, only that it is being subjected to abnormal conditions. So here's the correct way to avoid false readings and damage. The ECM should be tapped using only the fingertips of one hand. Use of the palm, fist, or any type of tool subjects the ECM to excessive stress. The force generated can cause both the circuit board and the outer aluminum case to flex and distort beyond design limits. Tap only on the top, the side with the MEM CAL door. This will minimize the chance of deflecting the ECM case into the electrical leads on the circuit board. Also, tapping close to the edge of the ECM, especially near the corners, is best. Once again, while using greater force may seem more effective at finding intermittent ECM faults, if you're not careful, the test itself may be the cause of the failure. For the full written procedure, refer to your manufacturer's bulletin.
It has come to the attention of Delco engineers that many ECMs are damaged when MEM CALs are replaced incorrectly. If excessive force is applied to a MEM CAL during insertion, the circuit board can be damaged. When excessive force is applied to the MEM CAL, the circuit board may flex, causing microscopic damage to the circuit board connectors. When a vehicle continues to run poorly after a MEM CAL change, many technicians think the ECM was bad before the MEM CAL change. In reality, the MEM CAL was damaged by rough handling. To install the MEM CAL, align the small notches in the ECM MEM CAL socket. Using as little force as possible, press down on the ends of the MEM CAL until the locking levers are rotated toward the sides of the MEM CAL. Do not, as some earlier instructions state, press on the ends of the MEM CAL until the levers snap into place. Pressing on the MEM CAL until the levers snap into place is likely to damage the circuit board. As this unboxed unit shows, pressing on the MEM CAL until the levers snap into place will overflex the board. Instead, a technician should use index fingers to pull the locking levers inward until they snap into place. With some ECMs, there is not much room to maneuver, but it is still possible to insert the MEM CAL. After inserting the MEM CAL, install the MEM CAL cover. Some MEM CALs have been manufactured with cork spacers on top. In some cases, the resulting loss of clearance can cause the board to flex. To avoid this problem, remove any cork spacers stuck to the top of the MEM CALs. For the complete MEM CAL installation procedure, refer to the Buick service manual.